Yes, we are live now.
Okay. So, good afternoon, everyone. Welcome to this third talk on cryptography and blockchain. In this talk, I'll try to give you a brief understanding of what blockchain is, why it is required, and what you can achieve using blockchain in real world. So, before starting, is my slides visible?
Yep.
Okay. So, let me introduce you. Uh, Let me give a brief introduction about myself. So I'm a third year CS student. I've been pursuing development for the past 2 years, and now I'm currently interested in blockchain research as well as development of decentralized applications. You can contact me on Silica at Prarabdh Garg or using GitHub. So let's talk about the problem of immutability. So, as you all know, data is the new oil in today's generation. There are companies, huge companies, that solely rely on data for their business. But if you think about how this data is stored, you will come to a conclusion that it is pretty easy for anyone to modify this data. So, like most of the data is stored in databases and files, and there is at least one person in every organization who has control over this, which could be dangerous. So, let's take an example of, say, Paytm. You pay someone rupees 100, and this transaction is stored in the database of Paytm. Now, let's say after 2 to 3 days, the CEO of Paytm decides to modify this transaction, and he changes the amount to rupees 100, and the amount is deducted from your bank account as well. Now, now in such a scenario, how do you verify that what was the original amount of the transaction? As there was only one copy of the transaction stored, and that has been modified, right? So this like, as you can see, this could lead to huge consequences, and hence we need to ensure that data, once it is stored, cannot be modified by anyone, like not even the uh, owners of the organization or the owners of the system. Right. So, one possible solution that people think of to make data immutable is to add timestamps which say that when the data was last modified. So, in the above example, let's say if I had a last modified timestamp uh, that was different from the transaction time the transaction was carried out, one could figure out that the transaction is maybe modified and incorrect. But if the owner or the malicious person has enough knowledge, he can easily modify the time of the transaction as well, or the last modified timestamp, because ultimately everything is stored as zeros and ones on your hard disk, and modifying the hard disk is pretty easy if you have the right skill set. So, and also imagine if we had a technology which could, allow us to maintain such immutable records. This would be immensely helpful for storing financial records, as well as for storing patents, for information about patents, and other information which we need to archive it for a long time, right? So this is where blockchain comes into the picture. So blockchain is, the basic fundamental idea of blockchain is, whenever you add some new data to it, the data, you also specify what all was stored in the database when this data is being added. So basically, if you divide your data into blocks, every new block that you add knows about all the blocks that were stored in the database previous to it, right? So this way, if you modify some block, the blocks after it would not reflect the same data that is stored in the block, and hence the uh, data structure would be invalid, and you could easily figure out that it was modified. So let's visualize this, and then we'll talk more about how this is done. So let's say you have this block A, right? And then now you add another block B, which has its own data as well as a copy of the previous block that was stored in the blockchain when it was there, right? So this is something like this would have its own data as well as the data that before uh, this block there was a block. Now let's say if I add one more block with data C, this would need to have a copy of A as well as B within it, right? So as you can see, this leads to a lot of page, wastage of space because we are essentially duplicating data every time we add new data, right? So one possible solution to avoid this wastage could be to instead of storing the entire block, we could use some sort of a technique to get the fingerprint of a block. So let's say uh, this block has a fingerprint F1, right? So this F1 is unique to this block, and this changes as soon as something in this block changes. So now instead of storing the entire block within the next block, we only need to store its fingerprint, let's say F1. So we basically store F1 here, and we are done. So this consumes less space because the fingerprint is smaller than the size of the block, and the size of the block could be huge if you are storing, let's say, multimedia files or videos. Now, when I add another block, let's say the fingerprint of B along with F1 is F2. Now in C, I only need to store F2 because if B is modified or F1 is modified, any of these is modified, F2 gets modified. So only storing F2 in C uh, helps me to maintain the data to make sure that the data that was there previous to it is not modified, right? So now how do we find these fingerprints? So for finding fingerprints, we use something called as hash functions. Hash functions are basically mathematical functions that take uh, d- take any arbitrary data as input and output a fixed length string, which acts as a fingerprint for that data. So, there are two important properties every hash function has. One is the avalanche property, that is, if you make small changes to the data, the fingerprint should change completely. And the other is from the fingerprint, you should not be able to get the data back. So let's visualize this, what a hash function looks like. So let's say I have some data A, B, C, D, right? And then this essentially is a 256-bit string, which represents the fingerprint of this data, right? So if I change a single letter, let's say I change D to E, you can see that the hash is completely different from the original hash. So these are essentially hash functions, and they are used to link the different blocks together to uh, make sure that data is immutable, right? So now, let's say I have this. Now, what if someone modifies this as well, and the modified fingerprint F3. Let's say he adds F3 here. He changes this F1 to F3 and calculates the new fingerprint F4, and he changes this F2 to F4. This is possible because essentially hashes are very easy to calculate, right? So like you could your own laptop could uh, essentially calculate up to 10 power 6 hashes per second. So hashes are pretty easy to calculate, and hence someone could do this and still modify the blockchain. So what we need is we somehow need to make adding new blocks a bit difficult so that it's not easy for a single person to change the entire blockchain. Also, what we need is somehow we need to uh, store multiple copies of the blockchain so that if someone tampers with one copy, we still have other copies to determine what is the true nature. So this is where mining comes in. So let's say this is a blockchain. We have block, we have some data, right? And then now to make addition of new blocks difficult, we have this nonce. So we modify this nonce one by one with the goal that the hash should contain the output hash should start with some minimum number of zeros. What this ensures that is that addition of new blocks to the blockchain is not easy, as you will need to iterate through a large number of nonces to get a hash value with the desired property that it starts with a fixed number of zeros, right? Also, what we could do is, let's say we have one user that has a copy that has this blockchain stored. Now, instead of storing this copy only with one user, we could actually distribute this copy to multiple users. This entire copy, what we do, we distribute this and it is stored with multiple users so that even if one copy is modified, we can basically revert back to other copies to get the original source of truth. So let's say if this copy shows this as the state of the blockchain, while these two have different last blocks, the data in the last block is different for these two copies. So what we do is we simply take a majority and like whatever the majority says is accepted as the truth. So here, two out of three blockchains show that uh, the data of last block is C, so we accept this uh, as the truth, right? So now even in this, there is a possibility that if someone controls more than 50% of the network, let's say uh, among these three users, if these two users are friends, they could together they could modify their local copy, and then suddenly D becomes truth, the truth instead of C. So this is actually a possibility in blockchains as well. This is known as the 51% attack. And to avoid this, we basically have to make sure that our network is big enough so that it is impractical for any single user to get hold of 50% of the network. So, are there any doubts till now? So let's continue. So how can we use it, and what are the various applications of blockchain? So since blockchain is decentralized, right, we saw that we generally distribute the blockchain over multiple users. Blockchain can be used to make transparent apps wherein every end user has a copy of the entire data that is stored. So I'm pretty sure you all must have heard about the recent WhatsApp policy changes and the stir it created. So the main problem there was end users, that is we, don't have any information about what data WhatsApp is storing and what data it is not storing. So, using distributed blockchains, we could develop apps wherein the end user can see everything that is being stored, and this helps us in making apps transparent and helps and gaining trust of users. So, another thing is we could use distributed blockchains to make applications where privacy of users is important. So since everything we are using is hashed, like uh, everything that is stored in the blockchain is stored in the form of hashes, it is pretty difficult to uh, get the original data only looking at the hash. Also, users on the network are usually identified using public keys and private keys, which are just big prime numbers, and they have no relationship with your true identity, and hence they could be used to uh, build apps where privacy of users is important. Another thing is that blockchain is immutable, so you could basically uh, create apps where a single source of truth is needed. So, uh, for example, if uh, you are, let's say, you want to store some data that, let's say, you need to store financial transactions only. Sticking with the example of Paytm. So, in financial transactions, you need a single source of truth, which should not be modified, which should be immutable, so that no one could actually uh, take more money than they are entitled to. So in such applications, blockchain is pretty helpful as it pretty much it is pretty much immutable unless uh, someone controls the more than 50% of the network. So another use of blockchain could be to automate stuff using smart contracts. What smart contracts are, we'll come to it in a bit. But let's say you are an insurance company, and let's say I have been admitted to a hospital for some treatment. Now, if I want to claim insurance for the treatment, usually at this time, what I have to do is I have to go to the hospital. I have to get the document stating that I have been admitted there and I have made this much amount of payment for my treatment. Then I take these documents to the insurance company. The insurance company then again goes to the hospital, verifies that the documents are correct, and that I'm not lying, and then after that, the insurance company releases funds to your account. Now imagine a situation where as soon as the hospital creates digital documents that you have been admitted there and your treatments costed this much amount, what if the insurance company was automatically able to verify the documents and release funds into your account without any manual intervention? This would not only save time, but this also helps to avoid errors which might creep in due to manual intervention. So let's see some examples of where blockchain is used in real life. So the most famous one is Bitcoin. Bitcoin is one of many cryptocurrencies that exist today, and blockchain is one of the building blocks of cryptocurrencies. Uh, so the advantages about cryptocurrencies is that they are not centrally controlled, which means that no one has control over issuing of funds, and no one has control over the data and related transactions. And this may give some unique properties to cryptocurrencies. Another use of blockchain is like another type of blockchain is Ethereum. So Ethereum also has its own cryptocurrency known as Ether. But along with that, Ethereum is a programmable blockchain. By programmable blockchain, I mean that uh, you can basically use it to write and run smart contracts, and basically you could automate stuff using the Ethereum blockchain. Apart from this, we have the the Hyperledger Fabric, which is a framework that is used to create private blockchains. So imagine if you are an organization that needs to archive some data in an immutable manner, but you don't want this data to be visible to everyone on the internet. Instead, you would want to allow certain type of authentication or access access restrictions so that only people in your organization can see the data. So this could be achieved using the Hyperledger Fabric. Another use of blockchain is the XRP blockchain. So XRP is basically used to convert one cryptocurrency into another, and it also helps to convert cryptocurrencies into conventional currencies like dollars or rupees. So there's a company called Ripple, through which you could make international payments with minimal cost. Like if you are aware, international payments generally involve a lot of taxes and lot of extra cost, but using Ripple you could uh, mitigate those fairly. So now we have been talking about what blockchain is and where all it is used. But you might be wondering, how do I actually use a blockchain, or how do I interact with a blockchain? So there are multiple ways of interacting with it. But if you are someone who is very new to blockchain, you will mostly be using wallets. So wallets are basically applications built over the blockchain that abstract away the complexities of the underlying blockchain itself. Uh, One note I wanted to make was you should not confuse these wallets with wallets of cryptocurrencies. So, wallets is a generic name given to any application that is developed over a blockchain, that is used to that users use to interact with the blockchain. So, however, if you are an experienced user or you want more control over how you can over your interactions with the blockchain, you could basically run a node on your local machine, and then you could interact with the blockchain using your terminal. Also, if you want to make end user applications that are distributed in nature, basically applications that instead of communicating with a server, communicate with a blockchain, you could use frameworks like Truffle, which are used to manage and deploy smart contracts, and which connect your apps to the underlying blockchain network. Right. So we have been talking about smart contracts a lot, but what exactly are smart contracts? So think of smart contracts as programs that are stored on the blockchain and are executed in a decentralized manner. So what I mean by this is, let's say you write some program, you upload it on the blockchain, and then this program is executed every time some event occurs. So let me demonstrate it. So let's say this is the so let's say this is a blockchain, and this is where your program resides. Now, since this program is on a blockchain, no one can actually modify your program. This could have a potential downside that if your programs have bugs, it might be exploited. But for now, let's say your program is correct, and it is actually stored on the blockchain. And this program says that whenever person A, so this program says if A pays to B, deduct 50%. So let's say whenever A pays to B, you want to apply some form of tax and deduct 50% from the amount what A is paying to B. So now what happens is, as soon as some transaction, let's say A pays B, is entered in this block, uh, this program is executed in a decentralized manner, and uh, another transaction saying that A pays 50% to, let's say, the program is also added to the blockchain. So what this essentially gives users is the functionality to automate a lot of tasks related to the blockchain. Now, one potential problem with smart contracts is that if if there is a malicious smart contract that has, say, for example, an infinite loop, the node that is actually trying to execute the smart contract will be stuck forever, and its resources would get wasted. Also, since smart contracts are nothing but programs, they need to be executed on some machine. So you need to in some way reward the person who's executing your smart contract. So uh, this is usually done through gas. So imagine gas as another form of cryptocurrency that you use to reward miners and people who are running your smart contract on their machines. So essentially, what happens is, for every instruction that is executed on your smart contract, the person executing it is paid some amount of gas, and while deploying the smart contract to the blockchain, you actually specify what is the maximum amount of gas you want to spend on executing every uh, program. So this prevents malicious smart contracts from hogging up the resources of the network, right? Also, another very interesting use of smart contracts is basically you could create your own cryptocurrencies, and basically you could use it to, let's say, raise funds for your startup. So let's say if you are a startup, and you need funds, you can create your own cryptocurrency. Di- uh, you can distribute them among people, and in exchange you'll get, let's say, ether. Now what then you could use this ether to fund your startup, and you could in turn give people with who have your custom cryptocurrency some added benefits like discounts, or basically the cryptocurrency could be treated as loyalty points. So, are there any doubts till this point? Okay, so there's a question about the nonce. So I'll maybe cover this after the presentation because like right now we are a bit further ahead. So I'll cover this after the presentation. Okay, so there's a question saying how can you give rewards to customers if it's decentralized? So like the entire blockchain is decentralized, but customers own certain amount of tokens, right? So let's say if you create the way custom cryptocurrencies work, it's say you create 100 tokens, right? And now there are users who are actually interested in your startup and want to invest. So let's say I am interested and I buy 10 tokens from you, and in exchange I'll give you, let's say, 10 ether. Now I have these 10 tokens. So since it is distributed decentralized, everyone knows that I have 10 tokens of the tokens you created, and now I could use these. So let's say in the future when your startup grows and your startup has pretty good value, I could sell these tokens back to you and in exchange receive ether. So you could in other way consider them as equity or stocks of the stock market, wherein you create some stocks and actually buy it. Okay, so let's move on. Okay, so now let's look at how to write smart contracts. Smart contracts are like essentially like any other programs. So there are multiple languages in which you can write them depending on which blockchain you are using to deploy them. I'll be giving you an example on the Ethereum blockchain, and the programming language I'll be using is Solidity. So Solidity has a syntax pretty similar to Python and JavaScript. So users that are even a bit experienced in programming might be able to understand what I'm trying to do, right? So writing smart contracts is pretty easy, but the challenge comes when we need to test smart contracts. So testing smart contracts is difficult because we essentially either need to simulate a blockchain network on our local computer, or we need to use some of the test networks that are hosted by blockchain developers. But these networks are uh, pretty heavily loaded and they are difficult to test on. So we generally use tools like Remix. Remix is in-browser IDE for writing smart contracts, which help us to simulate the blockchain and deploy our smart contracts. Okay, so let's see how to write smart contracts. Uh, so we'll write a simple smart contract wherein, let's say, there is a startup with two co-founders, and these co-founders have decided that we'll split whatever funds we get uh, in an equal manner, let's say 50-50%. So instead of keeping track every of the funds of how much funds they have received till now every time, they could decide to write a smart contract which could automatically divide all the funds into half. Like whatever funds are received on the address of the smart contract would automatically divide it into two, and then send it to the corresponding wallets of the two co-founders, right? So let's name this file split.sol. So in Solidity, you always start by specifying the level, the version of compiler you want to use. So I'll be using the 0.7.4 version of the compiler to compile the smart contract. Every contract begins with the keyword contract and the name of the contract, very similar to classes in Java. Now, our smart contracts needs to know the two addresses where it is supposed to send the funds to. So we'll store this in an array variable named addresses, uh, and uh, I can take the addresses from here. So this is essentially a dummy blockchain network that has been created by Remix, and there are 10 accounts on this network. I'll be considering the first two accounts as the co-founders, and I'll be using the third account to transfer money to these two accounts, right? So now we have the addresses. Now we need to create a function that is called every time someone pays this smart contract some ether. So let's call this function pay. Now every time a transaction is created with some ether being sent to a smart contract, uh, we have a variable known as message MSG, which contains the amount of ether that is sent and from where it was sent to, from where it was sent. So we'll basically take this and store it in a variable, and then we need to divide this by 2. So now here I wanted to make a note that we should not be writing like programs like this, because we are essentially adding one extra instruction. We are adding one extra instruction, which is of no use. We could have done like this, and the benefit we get is we need to pay less gas for every execution, because every instruction consumes gas, right? So it's better to write it in one instruction only. And now I need to transfer the amount to the two addresses. So I use a function known as transfer, which is an inbuilt function and which handles the transfer of ether from a smart contract to the specified address. And with this, we are ready to test our smart contract. So before testing, we'll have to compile the smart contract. Uh, So our smart contract is now compiled, and we are ready to deploy it on the blockchain. So whenever we deploy a smart contract on a blockchain, essentially what happens is this smart contract is stored in some node on the blockchain, and a unique address is assigned to this blockchain. So currently I'm using the virtual machine. So you won't actually be able to see how this is done. But let's say if I use some, if I want to deploy it on the actual blockchain, here I could actually specify the uh, address of the machine where I want to store the smart contract. But for now, I'll be using the VM only. Also, while deploying a smart contract, you need to select an account from which the smart contract is uh, deployed, and basically this is the amount from which the amount for gas is deducted. So here I've set the gas limit amount to uh, 30 lakhs. So this, like, different amounts of instructions take consume different amount of gas, but this essentially means that on an average I should be I the smart contract must be able to execute 10 lakh instructions. So yeah, on an average, uh, an instruction consumes 3 gas units. So I'll deploy this smart contract, and you can see the amount for gas has been deducted from this account. Now let's say account number 4 wants to make a payment of 20 ether to your smart contract. And so basically, uh, the way uh, the way other users interact with your smart contract is through public functions. Since our pay is a public function, any user on the blockchain can call the public function, give some amount to the smart contract, and the smart contract will automatically divide the amount into the two accounts. So let's see when I call the pay function, you can see that 10 ether has been deducted. Some extra ether has been deducted, which is the amount to execute the smart contract, and 10 ether have been added to the two accounts which were mentioned in the smart contract, right? So this is how we create a simple independent smart contract. We could also create multiple uh, smart contracts, deploy them, and then use them on our application. But deploying smart contracts on a real blockchain and integrating them with an application is a pretty lengthy process. And so I'll not be explaining it here, but you can ping me anytime, and I'll be happy to discuss and explain it to you. Also, I'll be providing links at the end regarding how you could learn the same on your own. Right. The last slide is like the last point I wanted to discuss is one of the most exciting applications of blockchain. These are known as distributed autonomous organizations. So these are basically organizations that run themselves without any owner or without any person on its payroll. These are made using a series of interconnected smart contracts along with the help of IoT devices. And essentially, once coded, these are publicly controlled, like no single person has complete control over the organization, and there is no manual intervention in the workings of the organization. So let's say we let's say I take an example of Ola, or for that matter any cab sharing platform, right? So we have this user who wants to go from uh, here to his friend's house here, right? And we have a vehicle. This is essentially a smart vehicle. that can communicate with the blockchain network. And we have two smart contracts. So let's say one smart contract specifies how to calculate cost of ride, and we have uh, so there are some network issues from my side. Am I still audible?
Yep.
Uh, okay. So I think this has hanged. So let me just explain you without the illustration. So let's say we have smart vehicles that could interact with smart contracts, and we have two smart contracts. One specifies that how a car would receive payment from a user once it has dropped the user to its destination, and the other specifies which car would serve which user based on the location, and similar to how Ola schedules which car should pick which user, right? So now, as soon as the user makes a request for a taxi, the smart contract which controls which taxi should serve which customer is invoked, and the smart contract instructs instructs some instructs the appropriate vehicle to go to the location and pick up the user. The user then specifies the drop location, and the vehicle uh, drops the user to the specified location, and then the second smart contract is invoked, which calculates the cost of the trip, and notifies the user about how much he has to pay. So uh, such in such organizations, there is absolutely no need of manual intervention, and they can be controlled through only smart contracts. So this is one of the most interesting use cases I find of the blockchain technology, right? So that's it. These are some additional resources if you're interested to explore the field more. We'll be sharing the slides later, so you'll get these links. Any doubts? So I remember there was one about the nonce. So let me explain that first. So why we have introduced nonce is that we want to make we want to make adding new blocks to the blockchain a difficult process, right? So what we do is we want what we now do is we say that the hash can only begin with four zeros. It cannot begin with anything else, right? Now, since uh, the person who's adding the block, the miner, cannot modify the data or the block number or the hash of the previous block, we need some number which or some data which the miner can modify to change the hash of the current block, right? So there is this field called nonce, which the miner modifies. Yeah, so there's this field called nonce, which the miner modifies and tries to get the hash that starts with four zeros. Now, hashes are random, so like you cannot predict if I'm giving some input, what would be the hash output. So essentially, the miner will have to iterate from one to all the way to uh, the number which actually produces. So let's say in this case the number 46409 produces a hash that starts with four zeros, right? So the miner will essentially have to iterate from 1 to 46409, try all numbers, get the hash, and then check if it starts with four zeros or not. So this essentially introduces some difficulty for the miner to add new blocks, so that it becomes difficult for a single person to modify the entire blockchain. So yeah, are there? Uh, okay, so there's a question about ICO. So yeah, ICOs are basically the custom tokens that I was talking about. So they basically act as stocks, and like stock markets have IPOs. When you create new custom tokens, there are ICOs wherein people can buy the your custom coins and then invest in your startup. Okay, so are there any other doubts? Slides will probably share uh, once the series of talks is over. We'll spam a WhatsApp message, or we'll try to include it with the YouTube playlist. We'll let you know mostly through mail how we'll be sharing the slides. Okay, so if there are no more doubts, I'll be in the launch for some time if someone wants to talk, and I'm closing the session. Thank you for attending.